Okay, I'm recording it. So yeah, so just to repeat so that we have it on recording. So what I'm going to explain today is basically how to use the Dynamoose library with TypeScript. So the idea is that it's like a ORM around Dynamo. And for people that have, played around or used MongoDB, it's quite similar. So first, just a quick thing. So I've added a new repository in our, GitHub, which is called Dynamoose example. So what I'm gonna show right now, everything is uploaded there. So you can just download it and run it to see how things work. So that you don't have to, struggle with issues. This one is like a working example, fully functional. So just a quick intro. So here is like an example of, for example, in the current apps that we have, here is how things look when communicating with the database. So let's say we have some, payload that comes. So we have some definition, let's say, of like a contract, some definition of the data that we are getting. And then what's happening is in every single, let's say, request to the database, or anytime we need to talk to the database, like as a developer, one needs to write like a lot of things. So, we have to manually parse those things, then pretty much create this whole object, which is basically an instruction for this driver for DynamoDB to that it sends it to the database, and then things get stored, retrieved, or whatever it is. So because this is a lot of writing, and this also because we're doing a lot of this. So the idea is that it's like prone to mistakes because one has to be careful what to write. So in Releasely, what I was doing was initially I did it the same way, but then I realized that it's taking actually quite a lot of time to do new things. And then, it's kind of a bit of a messy. So I decided, okay, we discussed with Andre as well, what ORM should we use? So I basically, I think, yeah, Andre suggested to use this Dynamoose. We looked into several different ones. So in the end, this turned out to be quite good. So the idea with Dynamoose, similar to, let's say, to MongoDB, is, we have, different types of objects. So one can use it, very like function oriented. So one can basically, do line by line. But I think the power of Dynamoose comes in this object oriented thing, where you can actually define the different types of objects, in the application, and then it automatically works out of the box. So you have to write very little code. So just as an illustration, so here in the repository, there's like one diagram that I've added. So the idea is that we have several different objects. So I would start first with the schema. So the schema basically, I mean, it's pretty obvious, but what it does is it defines what the table looks like, so that actually the application knows, what fields there are, what types those fields are, and so on. So if I go to the documentation of Dynamoose, it's actually documentation is very good. So if anybody that's implementing it, you can guys just look into it and see what's going on. So the idea is with the schema is you can define the different fields that you have. You can say, okay, I want this field to be required. I want this field to be of type string, or maybe like something else. And then actually what's good about it is that you can have a validate functionality, so that within this schema, you can actually validate that the value for this specific field is okay. So maybe you want to validate that it's an email or like a telephone number. So you can very easily do this without having to write extra lines. So this is all in one place. So that's what the schema is about. Then what I've done actually in this example is I have similar to how we did it in the apps repository, in the apps repos. We would have like a repository, and then this repository would actually take care of all the communication and talking to the database. So in the way I've implemented in this example the Dynamoose, we also have a repository. So the idea of this repository is that it just contains the CRUD operations to the database. So it doesn't have any business logic. It doesn't have any mappings, any fields, customly defined fields or anything. It just basically receives like the object. For example, if we're storing an object in the database, it would receive an object in a specific format, and it would send it to the database, and it's using the schema so that actually it knows how to talk to the database. maybe actually I can show you this example I've done. So what I've done is I've done like a sample. Imagine that, let's say we have a block, and in this block we have, articles, and then for each article, let's say a user is able to add a comment. So what I've done here is like a sample, like an example application where, one is able to add comments. So this schema I talked about, here's how it looks like. So let's say, as a comment, if I want to, define a comment, I need to know which article it belongs to. So I have this post ID, which in DynamoDB I define, let's say, as the hash key. Then I want to have like individual comment ID. So I want to be able to identify, to know what the single comment is. So that's why I have the comment ID, which I defined as a range key. And then you can see that, these are required. The types are strings for these two. And as I mentioned, you can have other fields. So let's say, for example, for the author, I'm validating that actually the string that's being stored in the database is a valid UUID. So in case, some invalid data comes, we can actually validate things here. And this can get actually very, very complicated. So we can have nested objects. So it supports pretty much all things that Dynamo supports out of the box. One can define them here. So, for example, we can have a field that it's called details. Then inside it can have another object, a list of objects. So here, for example, in the text, what we have is a list of strings. So let's say for each comment, except for the text of the comment, we can have, tags. So this schema, if you have a look into the database, that's pretty much what it looks like. So, I mean, this schema, it's pretty much defining this field. So it's saying, okay, this post ID is a string, comment ID is a string, and so on. So the idea is that once we have this schema, what we also need, which I mentioned, is like the repository. So the repository is like the actual CRUD operations. So let's say we want to, get a single comment by, its identifiers, which is post ID and comment ID, or maybe get all comments or get comments by all comments for a post or whatever it is. So the idea is that here we don't have any business logic. And what we are doing is, as you see, like if you compare it to the apps repository, which I gave as an example in the beginning, here, let's say you would have to write some queries. You would have to, say, okay, I would store these fields from this object and so on. So you have to do this manually. Here, what we are doing is we are expecting some object to come in, for example, like a single comment. Let's say we are creating a comment, and then we are just, using a method. So basically, we are invoking the create, let's say, method of this library, and then it just does everything behind the scenes. So behind the scenes, it actually creates these objects. It does, all the magic, so we don't have to write it ourselves. So in order for this to work, what we have to do is we have to, for each entity, for example, in this case, we have the comments entity. So let's say for each table, we need to define a model. So what this model does is actually says, okay, this model is for this specific table. So in our case, let's say we have this table, which is called personal example DB comments. So we're saying this repository is basically connecting the table to the model and to the schema. So this model, I forgot to say. So what we have, so schema is basically how this Dynamoose library talks to the database. But in order to actually get to the point where we store things in the database, we have to have some kind of, representation of the data that we are going to be storing or retrieving or whatever it is. So I think in the apps and in other repositories that we have, we call those contracts. So here, contracts, models, entities, pretty much the same. So what we would have is we would have a very simple class, which, if you see what I'm showing right now, which defines how this comment entity looks like. But the difference is that while the schema is like the representation of this object in the database in terms of columns, fields, and so on, this model here, it's a representation of how we use it in our application. So for example, you would see that we have comment ID, but comment ID is like we don't care about it in our logic because it's generated automatically, let's say, or post ID. So and then so when, let's say, talking to the database, the idea is that in the repository we want to send like this type of object, like a comment object, and then we want to fetch, again, this type of object. So in the repository, we are only working, if you see, we are only working with this comment
Yeah,
class.
sorry to
Yeah.
draw you back. What does the exclamation mark in the entity do?
Yeah,
I know
it's very,
mark.
yeah. So you can do it like this without an exclamation mark, but the idea is that because this doesn't have a constructor, I mean, TypeScript throws an error because it doesn't have a constructor. So if I want to do it properly, I would have to write a constructor and, you know, define those things here. So in order to save, like,
Yeah, okay.
to not have to do this, this is like a quick, you know, quick workaround, which doesn't affect anything else, because otherwise you have to, you know, either stop strict checking or like the other solutions to achieve this. It's basically you're affecting other functionality of, you know, when TypeScript is building the application. So yeah, it basically means that it's a required one. If it's like a question mark, you know, it's optional. So the idea is that, as I mentioned in the diagram, so this entity, the idea is that this repository that talks to the database, which is basically a representation, you know, it connects the table, the schema, and this entity. We wanted to only accept this entity and to send back an entity. So we don't want to work with any other formats here. So the idea is that this entity, what we can do, this is like not part of Dynamoose, but I think it's very useful as well. So we have this automapper like packaging node, which allows us, let's say, if we have two different classes, it allows us to, let's say, if we have an object that's, you know, with the type of comment, it allows us to very quickly, you know, turn it into another object without having to manually write, okay, you know, this field corresponds to this field. So the idea is that this DTO, this is like an abbreviation of data transfer object. So let's say we have like a user, and the user, let's say they want to, I don't know, to get a comment. So what the user will do is it would, you know, I don't know, through a REST API or through whatever it is, it will reach the logic where, you know, it fetches this comment from the database. So the comment from the database, it's returned as an entity. So this is like the internal format that we have. So like an internal contract, which is, you know, maybe with private IDs, maybe with some sensitive data, which we might need for, you know, internal use in the programming logic, but we don't want to expose this data, let's say, to the outside world. Maybe some internal IDs or some, I don't know, whatever is sensitive, and we don't want external people or external applications to know. That's why we have this entity data transfer object. So the idea is that internally we are working with the entity object, but externally when we're communicating to someone else, we are maybe hiding some fields or, you know, transforming some data to something else. So that's why we have two different, you know, class definitions. One is entity data transfer object, and the other is entity. So with this,
forgive me for interrupting you, but does it mean that that the service works with the same entity that the repository works? I mean, they work with data object.
Yes,
both
exactly.
service and the repository. Okay, thank you.
But you can, I mean, if you want, and you want, let's say, the Lambda function to only work with the DTO, you can here in this part, you can also have just DTO. So it's up to you. I mean, the idea is for Dynamoose, the Dynamoose integration doesn't need DTO at all. But I mean, I just wanted to include it so that, because it works out of the box, because you just have like one line which creates the mapper between the two objects. And then it's very easy to, and you can define custom, you know.
Yeah, my question was regarding the place where we actually perform the DTO transition. I see it where. Okay, thank you.
We can do it in the service, we can do it in the Lambda function, whatever you want. Yeah. Yep. But the idea is, if we need it at all, maybe we don't need this DTO at all. So yeah, it depends on the application, I guess. So the idea is that now, as a summary, what we have is for the Dynamoose implementation. So we have the repository, which basically ties together the schema, the database table, and this entity, which I discussed. So if the request comes with some object like entity DTO, I can actually show you an example. So for example, from release link. So if you want to create an owner, let's say, you know, in this owner, you would have these things, but as you see, you don't have like a owner ID or like created timestamp and so on. So the idea is that this would be the DTO representation, but then, you know, once created behind the scenes, it would also have, let's say, an internal ID, like an owner ID and so on. So it would have additional fields which are not available to the general public. So as I mentioned here, so we have the repository, and now what's remaining actually, this is also not part of Dynamoose, but this is more like a general I guess, architectural structuring the application, like how one should structure the application. So we said that in the repository, we just have CRUD operations. So we don't want to validate data. We don't want to have like business logic. We don't want to check there whether the user has the permissions to do this. So the idea is basically we create a service, and then this service contains all the business logic. So if you look into the flow, let's say I'm through Postman, I'm attempting to create a comment. In our case, this example that I have, I would, send a request to the Lambda handler. The Lambda handler would, receive my request, the request body. It would, convert this request body to an entity object, for example, and it would send it to the service. And then it's the job of the service to see, okay, this is user Michael. Does he have the rights to do this action? Can he do it? Is like the email field filled in? Is it the real email and so on? So all this business logic we want to do in the service. And then the service decides, okay, do we proceed to store the data in the repository, or maybe there's some validation, error. So we're going to interrupt. So the idea is that in this way, if we do things in this way, it's very isolated, where each component does only its job, and this way it's very easy to reuse things. Because tomorrow, let's say we want to have another service, which, I don't know, maybe with the comments one, I cannot think of an example, but let's say if we are having releases for Releasely, maybe we have another service which is used to parse releases. So we can have one service which is, storing the releases, fetching the releases from the database and so on, but we can have a separate service which is doing the actual release parsing logic, let's say converting from Markdown to like a structured object. So you can have a separate service, and internally they can still talk with those entity objects. And then once it reaches, the repository, then it knows how to do it in the database. So if you look into the code, so here it's very simple. So these are the definitions, let's say, of the comment object, very simple. Schema, it's pretty much the same, but this is from the perspective of the database. The good thing is that actually there's like an instruction in Dynamoose where you can say how, let's say, if you have a field that stores the creation date and the updated date, we can actually define those automatically so that we don't have to even mention the word created in our code. So we don't do this anywhere. So if you look into, so what I've done is I've actually done some tests just to show you. So if you see in the database right now, I have 2 records. And if I run my application, so what it's going to do is it's first going to create a comment. I mean, it's quite ugly here, but I didn't have time to make it properly. So it's going to create a comment, then, it's going to, create a second comment. It's going to update the second comment, and then it's going to fetch something. So it's going to get a single comment from the database, get comments for posts, get comments, by a specific author and so on. So the idea, what I've done here is I wanted just to show you how the different things work. So now you will see I have 4 comments. So I've just created those comments, and you can see that, this is like the DTO objects or like the entity objects I talked about. So in the service, you will see that what the service does, it's like the business logic. So imagine, for example, that you want to get like all the comments by a certain author. So if you look into the database details, you would see that in terms of primary keys, we have a post ID and comment ID. So in order to fetch, let's say, data for the author ID, what I've done is, let's say, I've added a global secondary index, which indexes this field, the author. And what I've done is I've told it to actually return, store only the keys. So let's say if I want to request the comments by a certain author, I'm going to use this index, and it's going to give me the primary key. So it's going to give me the post ID and the comment ID for all the comments of this author. And then what I have to do, so that it's kind of optimal, I would go and fetch each comment individually by its primary key. So that's basically the difference between the service and the repository. So here in the repository, you'll see that I have one thing which is called find comments by author ID. And what it does is it just, uses this index. So you can see, I'm using certain index. And the good thing here is I don't even have to know the name of the index, because I'm automatically fetching it from the schema. So in the schema, I've defined like, okay, this author ID, it has like an index. And then here I'm just using, in the repository, I'm just using the field author, and then I'm automatically getting its index. So what I'm doing here is I'm finding the primary keys of all the comments by this author. And then what I'm doing is for each of those, I'm actually fetching it individually. So you'll see these are two different functions in the repository, but in the service, it's basically, okay, first I'm finding those comments, like the primary keys, and then I'm fetching the individual comments so that I have all the data for those comments, like text, tags, and so on. So it's very easy to use. So you see, I don't have any queries anywhere. It's just, like repository, specifically the repository part, which is the main thing we're changing with Dynamoose. Compared to before, it's like, in most cases, it's like a single line. Or maybe, if you have sorting, if you have limits, it's different. And the good thing is, also we have this O keyword. So in case there's like pagination or there's limits, this actually allows you to not take care of pagination, and it will actually invoke the query to the database several times until it gets all the results. Of course, performance-wise, this is not very good to fetch everything all at once, but just I'm saying that there's like some nice hidden features in Dynamoose that one can use. So this model I just presented, so basically I said it's in the repository, so feel free to download it and try it out. There's you'll find like in the apps directory, there's like a DB definition as well, serverless file for the DB, which you can deploy. And the thing I just explained, it's actually in this article, maybe I'll include it in the repository as well. So it's basically an article how to pretty much achieve what I've done, what I've just presented to you for Nest.js. So yeah, I've modified things a bit so that it works, for regular Node.js applications, but this, entity to schema to entity TO, the repository with services, this is pretty much following, this example from here. So yeah, that's pretty much it. I mean, I can go a lot more in detail, but the idea is just for this to just be like an intro session. So I guess one can look into the documentation or just, ask if there's anything, that's not clear once we start implementing it into the existing apps. So yeah, that's it, guys. If you have any questions.
Well, it's cool. Thank you very much. But one question right from the start: I cannot access the repository. Is it something to do with?
I mean, let's make it public. We also will make this video public. I think it's a very cool video. Yes, so you will be famous, and I will try to put it in multiple groups. I think it's useful for everyone. We didn't share anything secretive there. So.
Yeah. So yeah, I'll
let's
make
it
the
public.
repository public. Just need to see where. Yeah.
And I have a little technical question about the sort keys. You know that if we add the sort key to the DynamoDB, we are capable to put totally different type of objects, but using the same hash, but different sort key.
Yeah.
How does Dynamoose come around this issue? Not issue, this capability of Dynamo.
So it can, like out of the box, it can sort by the sort keys. So that's quite straightforward. I'm not sure.
But the schema, I mean the schema, how can we define the schema for the same hash key, but different sort key?
I haven't had to use.
But usually it's not a good practice to store very different objects in one table. And it brings more complexity.
If you're using like a single DynamoDB table design, which they suggest once you know what you're doing, I guess we can do that. But I haven't had to do this until now, to be honest. So not really aware.
No.
I'm sure that it supports it because it's just an ORM around Dynamo.
Yeah.
So yeah, it should be possible. And then if something there, one can always hook into stuff and add custom logic.
And about the validation, does it work only one way? I mean, when you write something to the DynamoDB using Dynamoose, or it also works when you're fetching it from the DynamoDB?
It only works when you're writing right now. So the way I've done it,
Okay.
This validation also. Let me just share my screen again. So again, this validation, you can just do it like regular if statements or whatever you want. but I'm using like one validator package for Node, which gives a lot of the stuff out of the box. But the idea is that this is doing it only when writing, because imagine tomorrow, let's say we change our logic for certain field. We don't want, when users are fetching existing data to just get an error because our data is inconsistent with the new logic. So I think it's good to only do it when saving, not when retrieving. I think when retrieving, we should pretty much assume that the data is valid, or at least handle it as if it's valid.
Okay, thank you.
No issues.
I think this assumption is correct if you started from zero. But if you are refactoring an existing application, like we have, then it becomes a bit more complex. The data could be not so consistent according to schema. But I think maybe there is a way to start with like fully optional schema and with time make it more stricter, or do some migrations and other stuff to kind of speedify the schema accordance.
Yeah, there's only one small thing, but I think it's not related to Dynamoose. But if you guys, or maybe if we start updating, to the latest AWS SDKs and latest, libraries, then there's like one specific thing which, if you're handling DynamoDB streams, it's a single line which you need to kind of map the object to something else. So I spent like 3 hours trying to understand why it doesn't work. So if somebody is updating, to the latest versions of packages in DynamoDB streams don't work, I have this solution.
But you're also saying that it will work with streams. So because basically you have a trigger which will be triggered by DynamoDB and update or delete, which we could use theoretically to.
Yeah, I mean, this is on the entry point. So like these Dynamoose things, we're using it behind the scenes. So whatever we have as business logic until we reach the moment we need to interact with the database, I guess it can stay the same for the time being.
And have you seen anything related to performance? Like, is it? I assume it should be fine. Have you seen anything related to the performance?
No.
Related to the native.
No, I haven't tested performance, but overall, I don't think it should be a lot of overhead. I mean, yeah, this conversion to objects and stuff, this might slow down things a bit, but overall, I think it should be pretty okay. I can test it. It's not that hard.
I mean, maybe someone has done it already, so you can just find it.
Yeah. I'll try to do it. Yeah. Okay, and now I'm seeing this repository that I cannot change the visibility. So I guess it's like an MWF repository, but it doesn't allow me to change the visibility. So I guess maybe
I will change it in 5 minutes.
Yeah. Okay. Good. Any other questions or anything else? Anyone is interested in?
No, nothing from my end. I'm certainly trying this out. I've always been a big fan of Mongoose, so this looks.
I think it's very useful. I mean, theoretically, we should plan a task to try and migrate one of our applications, because most of our apps, they're much simpler than release. They only have 1 or 2 tables. They kind of have a schema as well, so it should not be drastically unstructured. So we can basically plan a migration in production on one of our simple apps.
Yeah.
Definitely. It was actually one of the reasons I wanted to share this thing with us, because everybody should know what is the benefit of using Dynamoose, and how beautiful actually code becomes, how easy to maintain it.
It's very easy, yes. Yeah. Actually, it's very easy. And it takes, like, if you need to write like a new object, it's basically 10 minutes to get things working end to end, without the business logic. So
it's amazing.
Maybe one quick question, like, does it provision any tables, or how is it
Does it have any auto-generation
infrastructure?
It has auto-generation of tables, so it can provision tables, but I've decided not to use it. So because I want to have strict control of, deletion of fields, addition, indexes, and so on. So in this example, I've done it on the serverless config level, but if we want, we can do it from Dynamoose itself. it's all about security, I guess, and data, whether we want the database to be accidentally deleted or not.
Yep. I think we are done then. Thank you very much. It was super helpful. And I will you'll share this video and you can put it on YouTube. I think people can benefit as well.
Okay, we can do that.
Yeah, thank you, guys.
Thanks.
Yeah.
Thanks, guys.
Bye.
Yeah.
Thank you very much.
Thank you.
Thank you. Bye.
Bye.